Hello, everyone. Really excited to be here today. My topic is about carbon management and its role in reaching the United States carbon neutrality goal. My name is Zhao. I'm a second-year student in the Master of Environmental Studies program. And recently, I'm involving in a project related to CO2 transportation in the US. Many thanks to Alan and Peter from the Clean Energy Conversion Lab to make this happen. First, I would like to show you some key figures. This is the famous Keeling curve. It demonstrates the carbon dioxide concentration in our atmosphere, measuring since 1958 in Hawaii. This is the very first evidence to show that there's increasing level of CO2 in our atmosphere, caused by human activities. Look at these two graphs. The graph on the left shows that we are increasingly emit more CO2 year by year, to over 35 billion tons in 2022. And if you look at the map on the right-hand side, it shows the CO2 emissions per capita. You can see that many countries are in dark red color, which means they are emitting a lot more per capita. And for the US, this number is 14.9 tons per capita in 2022. So now we all know the implications and threats of climate change on human societies, such as the increasing frequency and intensity of the flood. The melting of sea ice will cause the sea level rise. The increasing frequency of the droughts and extreme heat event will cause more forest fire and loss of habitats. So a few years ago, the Intergovernmental Panel on Climate Change, known as IPCC, has urged us to limit the global warming level below 1.5 Celsius degrees above the pre-industrial level. After that, many countries in the world have signed the Paris Agreement and made commitment on their carbon neutrality goals, including the United States, the world's largest economy and the major emitter, to pledge its, to reach its carbon neutral, to reach a carbon neutral economy before 2050. There are many pathways to reach this carbon neutral goal. For example, developing the renewable energy and clean energy sources to replace the traditional fossil fuels. This includes the wind and solar energy, the hydropower and geothermal. And for the clean energy sources, we have the very debated nuclear power and also hydrogen. These are really great solutions to climate change. However, the problem is these really need time to scale up. As for now, our world is still heavily relying on the traditional fossil fuels, with only 15% of the total energy consumption in the United States was produced by renewable energy in 2022. That's why carbon management could play a part. So when we say the term carbon management, it basically indicates two categories. One is the nature-based solutions. These include forest, soil, and ocean. And these are great natural carbon sinks and can store a lot of carbon. But today we are more focusing on the tech-based solutions. That include the carbon capture, utilization, and storage, known as CCUS. How many of you here today have heard this term? It's not too bad. And also we have a relatively new technology. It's called direct air capture, and also an application of CCS, the bioenergy with carbon removal and storage. Looking into this more deeper, this chart shows the process chain of the CCUS. So first, the carbon dioxide is being captured at the point source. This includes, for example, the industrial facilities, the power stations, or directly from the air. Then those captured CO2 will be compressed from the gas into liquid for transportation. And there are several means of transportation. This include pipelines, the ships, trucks, or railways. And then this liquefied CO2 will be either permanently stored underground in some geological formations or being reused as some feedstock to create some products or services. So this is a more detail about the carbon, how the carbon is being stored. As I mentioned, the carbon dioxide will be injected underground, but we have to choose the right geological formations. And the suitable ones include basalt or saline formations, the shale basins, or the depleted oil and gas reservoirs. And after that, this liquefied gas will just stay underground, trapped in the pores or form rocks reacting with the surrounding minerals. And the carbon dioxide could also be utilized in some ways. For example, the enhanced oil recovery is to pumping the CO2 into the oil reservoirs so that more oil can come out. And also it could be used in some industries, for example, creating the cement building materials and also some chemicals productions. Though it's a very promising technology, there are still many challenges remained. The first one is the costs. So from capturing the CO2 at the point source, compressing it from gas to liquid, and then transport it, we need the infrastructure and also operations to the storage site, engineering, and also maintenance. That requires a lot of money. And in addition, the CCS has relatively low economic motivation for those companies to do it. Although CO2 can be used in some commercial ways, most of CO2 has to be stored underground, and it creates no financial benefits for them. And the risks are of public concern. Well, some people may worry about the leaking, the accidents of CO2 transport, the pipeline ruptures, or whether it's safe to store it underground. However, we have to say that nothing is a completely risk-free process, and the carbon capture and storage is not any more dangerous than any other processes. And of course, there are some environmental injustice concerns. And I have to say that in our project currently, we are trying to minimize the costs, risks, and environmental injustice in the CO2 transportation routing. And we aim to optimize and find the most cost-effective way to transport CO2. Last but not least, there are still a lack of regulatory framework in the US for CCS. Although governments are actively supporting the CCS, for example, by implementing some positive policies, such as the famous Inflation Reduction Act, which raised the carbon tax credits substantially, and it's a great improvement to the previous tax credit policy. The US Treasury estimated that the tax credit will be about $2.3 billion from 2020 to 2029. And of course, there are also some federal government funding for the CCS-related programs, projects, and also research. One of the reasons I'm saying that CCS is particularly promising in the US is that there are huge amount of storage sites available in the United States. Look at this map. The green and red regions are all indicated the available sites for carbon storage. And this is massive. The United States Geological Survey says that the storage capacity of the carbon storage in the US is approximately 3,000 metric gigatons. That's equivalent to 500 times of the 2011 annual emission in the US. So the US could really be the leader of the carbon management in the world. So looking ahead, we must combine all the tools we have in the toolkit to reduce the carbon emission. We should keep up with the natural solutions, for example, to the wetland restoration, the forest management, and also the soil carbon storage. In the meantime, we should also develop our climate technologies, for example, the direct air capture and CCS. So the direct air capture is a relatively new one, but it's still very expensive. But the advantages of it is it can capture the CO2 anywhere you want, so it's more flexible. So we are not powerless, and we have the agency to make the situation better. And we cannot achieve the carbon neutral goal without the carbon capture and storage. Thank you very much.